Hello students, welcome to Legacy AI Academy. In this video, we are going to discuss about recent discovery of gravitational waves that has been detected in the universe. So we are going to discuss what are the gravitational waves, how are they generated, and what is the significance of this detection as far as the field of astronomy and cosmology is concerned. So let us try to understand what has happened recently. So scientists from different universities have found evidences that suggest that universal is replete. That means universe is filled up with what we can call as low frequency gravitational waves. Basically, if we try to understand in brief, gravitational waves are a type of ripples. Obviously, ripples are like, suppose you have a standing column of water, a standing tank of water, or ponds are there, and if you throw a piece of rock in this pond, what happens at the point of impact? You have the ripple like waves are generated. So gravitational waves are something very similar, but these waves are generated not in a lake or pond, but in the fabric of space-time. In later part video, we are going to discuss what do we mean by the term space-time. And basically, if you believe the Einstein's theory of relativity, it is believed that the gravitational waves are created or generated when huge objects, huge celestial bodies such as planets, stars, galaxies move around, collide, and merge with each other. So Einstein, as we have discussed in his GTR, that is General Theory of Relativity, has predicted about the gravitational waves almost 100 years before the practical discovery of the waves. Thus, researchers have concluded that these waves create a cosmic background hum, a kind of cosmic background noise, disturbance, which can be heard and that permeates the entire outer space. And it's really actually the first time that we have evidence of just this large scale motion of everything in the universe. Till now, the waves that we have recorded were very high frequency gravitational waves, but this is the first instance of recording of the low frequency gravitational wave. So how it was achieved? Now, obviously, as we have discussed, the high frequency gravitational waves were first detected in year 2015 using a very well-known experiment and observatory that is called LIGO detectors, that is Laser Interferometer Gravitational Observatory Detectors. But these were as of high frequency, believed to be produced by merger of two relatively smaller black holes that took place somewhere about 1.3 billion years ago. And since 2015, all the detections that has happened till now were also high frequency wave. But now, due to the recent discovery of low frequency wave, a lot of things have changed. Now, in a bid to discover low frequency gravitational waves, scientists use an entirely different technology as compared to the LIGO method, compared to what we have used in year 2015. Basically, the researchers used 6 large radio telescopes around the world, including obviously the one in the Pune that is run by IUC AAA, to study objects such as pulsar. So, what is a pulsar? Pulsars are basically nothing but a very distant, very far beyond a rapidly rotating neutron star. Neutron star develops when the star dies after the supernova explosion, and if its mass is what we can say is about 1.5 times greater than the mass of the sun. So when such a star dies, it creates a neutron star which start to rotate rapidly around its core, and during the time of rotation it emits pulses of radiation. It's what we can call as a pulsating radiation, and which is observed from the earth as a bright flashes of light, and that is why we call the stars as a pulsars. So such a radio telescope basically deals with the study objects such as pulsar. And this is where the importance and significance of pulsar comes in picture, because when they emit these pulses of radiation, it basically emits in the form of bursts, and these bursts takes place at extremely precise interval, and thus scientists can use this pulsar as cosmic clocks. And thus, after examining almost 25 pulsars over 15 years, it was noted that some of the signals from these neutron stars arrived a little early, while a few others were late, and this discrepancies in the time taken by signals to reach the earth ranges somewhere to a very small fraction of second, that is a millionth of second, you can say. And thus scientists propose that these inconsistencies in the arrival of these signals were due to deformities that were being caused in the space time by the movement of the gravitational wave. You can try to understand it like this. For example, if a boat is moving in the sea, and if there is no big waves in the sea, boat can move with a constant speed. But suppose a waves that are generated in the sea, now due to this generation of these large waves, what will happen? Boats will take much longer time to reach the same place, same destination. The same thing happens in the case of space-time as well. As the gravitational waves propagate in the space-time, it creates a ripple, and these ripples actually interfere with the movement of this radiation that is coming from the pulsar stars. So what basically produce these gravitational waves? If we try to study this slightly in more detail, the scientists said that low frequency gravitational waves, which have been discovered recently, probably has emerged due to the collision of a pair of very large monster black holes. Now, black holes are generally an area of very high density, very high mass, and the density and mass is so higher that even light cannot escape these regions. The black holes are generally found at the center of galaxies, and thus it is believed that these detected gravitational waves have been created due to such a collision of a pair of very large black holes, which can be millions of times bigger than the sun, as per the researcher. And such large black holes are usually, as we have seen, found in the center of galaxies. This you can see is a kind of image. What we can say is imaginary image that has been constructed. This is one galaxy with the center of black hole, and this is the galaxy with the center of black holes. And when the galaxies collide with each other, it creates a, what we can say, very powerful gravitational waves. So how important is this discovery? Now, latest breakthroughs provides enough data to the scientists to suggest that there is a gravitational wave background. Gravitational wave background means all the time in the outer space, gravitational waves are continuously moving in a kind of background noise that exists in our universe. And thus, these background noises are not of the same type. For example, when you talk about the electromagnetic radiation, these are of various different wavelengths, such as we have radio wave, we have the ultra wave, ultra waves, then we have the infrared waves, and we have the visible light spectrum. So similarly, gravitational waves also having a different wavelength, and thus they have an entire spectrum of varying frequencies and energies. And thus, once we are able to examine a lot of different low frequency to high frequency gravitational waves, it will help scientists to expand their knowledge about the nature and also shed light on how the evolution of universe has happened since last 13.5 billion years ago. It will thus also help them in gaining more information about the environment around the massive black holes. Now, if you go back to understand that how and when the theory of gravitational wave arose, we can trace back it to the Newton's theory of gravity first. As we know that Newton has given this formula where he has said that every celestial body having certain mass attract each other. This force is equal to or directly proportional to the product of the masses of celestial bodies and inversely proportional to the square of the distance. And that is where you have the very famous formula, gravitational formula, given by the Newton. Newton said that every celestial body attracts each other with a certain force, and this force is called as gravitational force. But where Newton failed is he was not able to explain that how these bodies are attracting each other, what kind of forces they are generating that is attracting the bodies toward each other. And also, since this attraction is very instantaneous, that means there must be some force that is acting at a same point of time or acting at a very shorter period of time. And then Einstein came into picture, and Einstein in his special theory of relativity said that nothing can travel faster than light in our universe. Thus, if gravitational force is acting instantly, that means gravitational force must be traveling faster than light, and this is again violating the special theory of relativity. And to explain this dilemma, then 10 years later, Einstein published his general theory of relativity, where he explained that basically space and time are not separate. Space and time are not separate, but these are a single continuum. That means there's a fabric like a space and time, for example, as you can see from this picture here, and all celestial bodies are moving in this space-time fabric, and the space-time fabric basically becomes distorted due to the movement and positioning of the celestial bodies. For example, if you take Earth and Moon in case here, Earth is very heavier, so due to this high mass, Earth will distort the space-time around it. And then we have the Moon. Now Moon will start to rotate and will start to move toward the Earth because of this distortion, because a kind of slope is being created here, and Moon will also keep rotating around, revolving around the Earth because of this distortion caused by the celestial bodies in this case. And these distortions are the one that generates the gravitational waves as per Einstein. Thus, he compared gravitational wave with the ripples in space-time, just like moving boat in water creates the ripple. And it is these ripples that Einstein has called the gravitational waves. Now, what is space-time? So, first of all, a space-time concept was given in the special theory of relativity, where Einstein explained that space and time do not exist as independent entities, but basically it is a combination of three dimensions, that is height, length, width, and also one dimension is of time into a single four-dimensional continuum that is known as a space-time. We can try to understand this For example, we require all four together to have a proper understanding of meeting with a friend. For example, if you want to meet your friend, you can just tell him or her that we are meeting at this particular place A, but you also have to tell that you are meeting at this particular time T. Otherwise, your friend will be waiting for all time or all throughout the day. Similarly, you cannot tell someone that we'll meet for. You also have to specify the coordinates where you'll meeting. Otherwise, people will be waiting at different parts, different regions of the country. So Einstein thus further added that the body is moving in the space, it would affect time also. Not only the space around it is distorted, but time itself also becomes distorted, as you saw earlier, and thus space and time are interval. And this has been further explained in the general theory of relativity. And that is how the Einstein theory of gravitational differs from the Newton's theory of gravitation, because Newton said that space-time is a straight, what we can say, undisturbed kind of space is kind of undisturbed kind of medium, while as per Einstein, due to the movement of different celestial bodies, space-time has become distorted, as clearly seen in this picture. The space-time is not mere transparent, static or fixed background to all the events. Rather, it is flexible and malleable. The space-time interacts with matter, influenced by it, and in turn also influence the events that take place there. And that is where Einstein said that the light which is traveling at the fastest speed in the universe also becomes distorted. The time taken by light to reach at certain places also changes because of this distortions produced in the space-time fabric. Thus, that is why we are comparing the space-time with a soft fabric that responds to and get deformed by a heavy object that is placed on it. Now, coming to the recent discovery, that what is the significance of the discovery of the low frequency gravitational waves in our universe? So obviously it will overcome the limitations of the electromagnetic waves. For example, if I ask you today that how we are able to see into the universe, your answer will be by detecting the electromagnetic waves that is radiated by different celestial bodies in the universe. But the problem is that only 5% of the universe emits electromagnetic radiation, which we can see from our present day technology such as telescopes. 95% of our universe is made up of what we call as dark matter and dark energy, which does not emit any kind of light or any other kind of electromagnetic waves. Thus, to look and to inspect, to understand these 95% of the universe, it cannot be done by the conventional method of electromagnetic waves detection. We have to go and look at the detection of the gravitational waves, because most of the cosmos otherwise remain invisible to astrophysicists and astronomers. Thus, gravitational waves essentially give us this ability to see what remains invisible to us in the universe. They can tell us about our origin and answer fundamental questions about outer space, such as how different galaxies have emerged and evolved over the entire course of the universe. So that is all about this particular video. I hope you understood the concepts about the gravitational wave. If you like the video, please hit the like button, share it with fellow aspirants, as well as subscribe to our channel for more such content. Thank you.